Hello students, let's do congruency. Congruent triangles, exercise 21. Exercise 21 is on page number 233. Question 11. In the given figure, we need to prove that triangle ABC is congruent to triangle DCB, and we also have to prove that AC is equal to DB, these two sides. Okay, so first, now triangle ABC. Now this is the triangle ABC, the one in green, and triangle DCB, the one in blue. We have to prove that these two are congruent. So that is the first thing that we need to do. And now remember these 5 axioms or conditions of congruency. We're going to use one of these to prove that these two triangles are congruent. Let's see which one we can use. So let's begin by saying in triangle ABC and triangle DCB, let's see what is already given to us. AB is equal to CD. Can you see that? AB has a single stroke and CD has a single stroke. That means these two sides are equal. This is already given to us. So one side is already given to us. Now this side AC is not given to us and CB or BC is not given to us. But can you see that BC is a side that is common to this triangle as well as to this triangle? That means this is a common side. So we can say that CB is equal to CB because it's common. So we have one side that's given to us, one side that is common. Now this side we don't know. Now what else is given to us? You can see this right angle here, isn't it? A, B, C. Here B is a right angle. Similarly here B, C, D. This is a right angle. So that has been given to us. So we can say angle ABC is equal to angle BCD is equal to 90 degrees. This is given. So what are the things given to us? Two sides and an angle. Now let's look at the two sides. This is one side and this is one side and this angle is in between. So this is the included angle. Similarly here, this is one side, this is the other side, and angle C that you can see is the included angle. So let's see which axiom we can use. Two sides and an included angle. So here we have side, angle, side. So this is the included angle. So we have two sides and an included angle. So we can use the second condition of congruency or the second axiom. So we can say triangle ABC is congruent to triangle DCB because of the SAS axiom. So now we have proved this. Now here we have to prove the next thing. So first thing we have proved. Now the next one is AC is equal to DB. Can you see AC and DB are corresponding sides and these two triangles are congruent. That means corresponding parts of congruent triangles will always be equal. So we can prove that these two are equal because of this. So we have proved this also. Question 12. In the given figure, we have to prove a few things. So figures given to us, we have to prove. The first one is we have to prove that triangle AOD is congruent to triangle BOC. Now let's see where that is. Angle AOD, that is this triangle. Let's write that as 1. We'll write it as 1. This triangle is congruent to triangle BOC. BOC, that is, this is 2. So we'll mark this as 2. So we have to show that this one is congruent to this one. These two triangles are congruent. Now, based on these 5 axioms or conditions of congruency, let's see what we can apply to prove that these two are congruent. So let's write down that question first. We have to prove that. So let's begin by saying in triangle AOD and triangle BOC, what do we notice? Can we see AO and OB? Can we see that these corresponding sides are equal? It's already given to us. Also here OD and OC, those corresponding sides are also equal because you can see two strokes. So we have two sides. So now we have this side and this side that are equal, this side and this side that are equal. So let's write that down. So here we have OA is equal to OB and OD is equal to OC. It's already given to us. Now let's look at the third side. Now this is the third side. We don't know anything about this side. Here also we have the third side. We don't know anything about this side. Now So since we don't have a third side, we only have two sides, we have to look at this one, the second axiom, two sides and one included angle. Okay, now let's see if we have something like that. Now here we have two sides, and which is the included angle here? This one. Let me mark that and show you. So this angle in blue is the included angle because it's between these two sides. Similarly, on the other side, we have two sides. So this will be the included angle. Let me mark that also. So that is the angle in red. Now, can we say something about the angle in red and the angle in blue? That is angle AOD and angle BOC. Can you see that they are vertically opposite angles? These two angles are vertically opposite angles. And what do we know about vertically opposite angles? Vertically opposite angles are equal. So let's write that down. So that is angle AOD is equal to angle BOC, and what's the reason? They are vertically opposite angles. So now what do we have? We have two sides that are equal and the included angle is also equal. So we can use this axiom, side, included angle, side. So we can say that these two triangles are congruent. The two triangles are congruent based on the SAS axiom. So we have proved this. Now the second one is we have to show that AD is equal to BC. Now where is that? That is this one. AD is equal to BC. These are the two corresponding sides of these two congruent angles. And since these two triangles are congruent, then we can say that the corresponding sides are equal. So in that case, these two sides are equal. So we can say AD is equal to BC. And what is the reason? Corresponding parts of congruent triangles are equal. Okay, because they are corresponding sides of these two congruent triangles. The next one is we have to show that angle ADB, which is that angle ADB, that is this angle here. This is the angle. Angle in green is angle ADB. We have to show that that angle is equal to angle ACB. So ACB. So this is that angle, angle C here. The angle in blue. So the angle in green and the angle in blue, we have to prove that they are equal. Now, as you can see, both these angles are part of these two congruent triangles. And we know that in two congruent triangles, corresponding angles are equal. And these two are corresponding angles, so they are equal. So we can say angle ADB is equal to angle ACB, and the reason is CPCT. Corresponding parts of congruent triangles are equal. Question 30. ABC is an equilateral triangle. We have ABC. So this big triangle is an equilateral triangle. What is an equilateral triangle? A triangle in which all three sides are equal and the three angles also are equal. So, in an equilateral triangle, AD and BE, let's see. Now, this line in the middle is AD and this line is BE. So, let's name this as E here. So, this is BE. Now, these are perpendiculars to BC and AC respectively. That means AD is perpendicular to BC. AD is perpendicular to BC. What is the meaning of a perpendicular line? It is a straight line which cuts another line at right angles. So it's 90 degrees here. Similarly, BE is a perpendicular to the line AC. It's cutting that line at 90 degrees. Now we have to prove that AD is equal to BE. That is, this perpendicular is equal to this perpendicular we have to prove. Now we have all these axioms here. Now based on this, first we're going to prove that two triangles are congruent. Only then can we say that AD is equal to BC. So let's begin by saying, this is the question. In triangle ADB, which is ADB, ADB, this triangle here, ADB, that is here, ADB, this is 90 degrees here, this is the first triangle, and triangle BEC, which is BEC, we have BEC here, so this is the second triangle. So we are looking at these two triangles. We are looking at this triangle and we are looking at this triangle. So remember, we are looking at ABD, that is triangle here, and we are looking at the triangle BEC, which is down here. So I've taken that out from there to show you ADB. That is this triangle ADB. Now we are looking at the other triangle BEC. So this is the second triangle, triangle BEC. So in these two triangles, so keep this in mind, this is the triangle we're looking at, and this is the triangle that we are looking at. In that, AB is equal to BC. Now let's see. AB is equal to BC. How do we know that? Because they are the sides of an equilateral triangle. And sides of an equilateral triangle are all equal. So AB is equal to BC. We're trying to look at sides that are there for both these triangles. So this is one side and this is one side. So that is equal. Then look at angle ADB. Angle ADB, that is here, that is 90 degrees, isn't it? Similarly, angle BEC. BEC here, that is also 90 degrees. So the corresponding angles are 90. So that is already given to us. Then we also have angle ABD. That is this angle in red. Angle ABD is equal to angle BCE. Which one is that? How are they equal? This is the one. How are they equal? Because they are angles of an equilateral triangle and they are all equal and they are 60 degrees each. So angle A is 60, angle B is 60 and angle C is 60. So these two angles are equal to 60 degrees. Now why did we take only these two? Remember, we are looking only at this triangle and this triangle to prove that they are congruent. Okay, so now what do we have? We have a side and we have one angle and one more angle. So we have two angles and a side. So we can say that this triangle ABD is congruent to triangle BEC by using the angle side axiom. There are two angles. Now here there are two angles and a side. Here also there are two angles and a side. Now what is the difference between these two? In this one, the side is an included side. That means it should come in between the two angles. So here we have one angle and one angle, but this is not the side we are talking about. We are talking about this side. Okay, BC. So this is not an included side. That's why our axiom is angle, side. So we have proved that these two triangles are congruent. This triangle and this triangle are congruent. So that means AD and BE will be equal. And how are they equal? Because corresponding parts of congruent triangles are equal. So they are corresponding parts of two triangles which are congruent. So only because we have proved this, we can say that AD is equal to BE. Now, the next thing that we have to prove is BD is equal to CE. Where do we have BD? BD, this is part of this first triangle. Then we have CE, which is part of the second triangle. So we have to prove that BD is equal to CE. As you can see, they are corresponding sides. They come next to the right angle. They are corresponding sides and they are corresponding sides of two congruent angles. So they will be equal. So what is the reason? CPCT is the reason and hence we have proved it. Question 14. Use the information given in the following figure to prove that triangles ABD and CBD are congruent. So we have ABD and we have CBD. We have to prove that this triangle and this triangle are congruent. That's the first thing we need to do. So let's begin by saying in triangle ABD and triangle CBD. Now let's look out and see what is given to us. As you can see, AB is equal to BC is given to us because of the single stroke and AD is equal to CD is given to us because of the double stroke. That means two corresponding sides are equal. So that is given to us. Let's write that. So we have written that. That's given to us. Now these are two sides that are equal. Now let's look at the third side. The third side is BD. And as you can see, this side BD is common to triangle 1 here and it's common to the other triangle 2 here. So this is also equal. BD is equal to BD. So we can say BD is equal to BD because it is common. So now as you can see, we have three sides that are equal. 1, 2, 3. Three sides that are equal. So which axiom can we use? We can use the first axiom, which is side, side, side. So we can say that these two triangles are congruent by the SSS axiom. So we have proved the first thing, that these two triangles are congruent. Now we have to find the values of x and y. Can you see x is here? So let's look at x first. Now if you can see, you can make out that angle CBD, that is this angle here B, and angle ABD, that is this angle here 50, they are equal, isn't it? Because they are corresponding angles of these two congruent triangles. So they are equal. So let's use that. Because we are going to find out x, we have chosen this angle. Okay, so let's write angle ABD is equal to angle CBD, that is CBD. We're talking about these two angles here. The angle in yellow and the angle in red. Now angle ABD is 50 degrees. So let's write that here. So here we can write 50 degrees is equal to angle CBD. And how much is angle CBD? X plus 5 degrees. So this is x plus 5 degrees. So now this has become an equation. So we're going to solve it like a linear equation. Why are we doing it? Because we want to find the value of x. So here x plus 5 is equal to 50. So we're going to leave x alone. And on the other side we have 50 degrees. We're going to transpose this 5 degrees from this side to the other side. So plus 5 will now become minus 5. Minus 5 degrees. So we have found the value of x. How? 50 degrees minus 5 degrees is 45 degrees. So we have found the value of x. So x is equal to 45 degrees. So we have used this part to find the value of x. Now where is y? Y is this side. So we have to use this part to find the value of y. So here angle ADB, the angle in red, and angle BDC or CDB. Now this angle in yellow, they are equal. Why are they equal? Because they are corresponding angles of two congruent triangles. So let's write that. So we can say angle ADB is equal to angle CDB. So how much is that now? How much is angle ADB? Angle ADB is y minus 7 degrees. So let's write that. So y minus 7 degrees. This is equal to angle CDB, which is 38 degrees. So that is equal to 38 degrees. Now we are going to solve for y. So this is again a linear equation. So we are going to say y is equal to, remember this is an equation, y is equal to 38 degrees, and we're going to transpose this minus 7 to the right hand side. It's going to become plus 7. So this is plus 7 degrees. So we are going to find the value of y by adding up these two. 38 plus 7 is 45. So we have found the value of y. Y is also 45 degrees. X is 45 degrees and y is also 45 degrees. Question 15. The given figure shows a triangle ABC, that is ABC, this triangle, in which AD is perpendicular to side BC. AD is perpendicular to the side BC. And BD is equal to CD. BD is equal to CD. Let's mark that. So the perpendicular has cut this line into two equal halves. That's why these two sides are equal. Now we have to first prove that ABD triangle, that is ABD, that is this triangle. This is the first triangle, and the other side ACD, this is the second triangle. We have to prove that these two are congruent. So let's begin by saying, writing the question, and in triangle ABD and triangle ACD, what can we see? First we can see that BD and CD corresponding sides are equal. Okay, now let's write that down. So AD is perpendicular to BC, it's given, and BD is equal to CD is also given to us. So this is one side. Let's look at another side. Now this is the other side and this is the corresponding side, but we don't know anything about it. Now let's look at the third side. It is this perpendicular line, and that side is common to both. That means AD is equal to AD because it is common. So AD is equal to AD, it's common. So we have two sides. We don't know anything about the third side. Let's look at the angles. Angle ADB. Angle ADB is this angle here, is equal to angle ADC. That is the red and the blue angles, and they are equal to 90 degrees because it's common. Okay, so they are equal to 90 degrees. Now, we are going to prove that these two triangles are congruent by using this information. We have two sides and we have an angle. So let's see the two sides. That is this side, and the angle is in between. This side and this side, and the angle is in between. That means side, angle, side. So let's use this side, angle, side and say that these two triangles are congruent. And what is the rule? What is the axiom that we have used? Side, angle, side. So we have proved that triangle ABD is congruent to triangle ACD. So that's the first question. Second question is we have to prove that AB is equal to AC. AB is equal to AC. As you can see, they are corresponding sides of two congruent triangles, and we know that corresponding parts of all congruent triangles are equal. So let's write that AB is equal to AC because of CPCT. So we have proved the second one also. Now we have to prove that angle B is equal to angle C. Now where is angle B? Angle B is here. This is angle B, this side, and we have angle C here, that on the other side corresponding. As you can see, these two are corresponding angles and they belong to two congruent triangles. So we can say that the two angles are equal because of the reason CPCT. So we have answered all three questions and we have proved. So hence we have proved it all. So with this, children, we come to the end of this exercise. Thank you, children.